All right. Thank you for that. Okay, Assalamu alaikum. Good evening, everyone. Welcome to a new session of the GCP MENA days. My name is Nabil. Another share with you on Google Cloud topic. Today, we're going to talk about BigLake, a new service that was introduced a couple of months ago by Google from on the data analytics services. So I'm gonna talk about a few of the other topics in order to introduce afterwards. BigLake, what is it, and what does it come to solve that the previous products didn't have already. So first of all, I'm gonna be talking about data lakes and data warehouses because this is where this topic will land at the end. So we'll start with data lake. So what is a data lake to start with? So the definition that we're going to be using here is scalable, secure data platform that allows enterprises to ingest, to store, to process, and analyze any type of volume of information. And of course, this could be many different types of data, structured, semi-structured data, unstructured data could be coming in different formats, either batch or streaming, and it got many different uses. So maybe SQL data analysis, machine learning, and also data. It doesn't have to be on the cloud. It doesn't have to be to deal with data just on the cloud, but it could be on premises, it could be on edge, device data, and so forth. So cloud is not the only choice there, but there is a lot of benefits and advantages of having a data lake in the cloud. And this is basically what it brings in. So it brings in data across different data sources together. And we want to basically put it in a uniform format. So it could be coming from transactional databases, could be like offline files. You might have like spreadsheets in different formats, legacy applications as well. So all that data, what we want to do to make it in a good use is to replicate all that, whatever format it is in, and bring it into a data lake. So it could be of a good use later on. So some key considerations in there to when building a data lake. So things that we need to ask ourselves is, can it handle all the data types that we have? Because that's the purpose of a data lake. So it might be like a big repository where we want to put anything in there. Structured data, unstructured data, videos, images, relational databases with backups and things like that. So we need to have a look if a data lake will support all those kind of stuff. And can it scale? And this is one of the issues when you are on premises. You struggle with scaling to a certain extent, but in the cloud, that's kind of the issues where you don't really face, because storage in the cloud is pretty much elastic, and we're going to see kind of what kind of storage solutions we have in GCP to as a data lake in them. And then high throughput and ingestion, pretty much. Can your data lake meet these demands for high throughput and ingestion over time? So and does it support both of them at the same time? So and then from security perspective, can you actually give granularity in terms of security to not just the whole data lake as a whole, but granularity into the objects that are inside the data lake? And from connectivity perspective, obviously, the purpose of having a data lake is to bring in all the data there in order for later on to connect that data, do some kind of transformation with it, and have it to connect to other tools, and maybe transform that data and transfer it to other data solutions as well. So does it have actually ability to connect to tools that will help us to move the data about later on and do transformation with it? Whereas a data warehouse, that's briefly what a data lake is. So a data warehouse is different. So a data warehouse is, obviously, it works at an enterprise level. It is used to do analysis and reporting. On reporting, like you would be basically using the back end of it, you would be using things like dashboards. You will be running queries at a very large scale. And it is really for structured and semi-structured data, and basically for this data coming from different sources as well. So it is actually suited for this ad hoc analysis, do some kind of, like I said, custom reporting, dashboarding, and it should basically be able to store a huge amount of data, current and historical data, in one place in order to do some kind of business intelligence later on based on the analytics and the results we can get from analytics that we do at scale for data that is brought in there over time, making it kind of a primary component for BI, pretty much business intelligence, to make those get some insights into data historically, and being able to help us to make those business decisions based on those findings. So, like I said, it does consolidate data from many sources, which implies some sort of schema that we need here. So it have a unified schema. So all the data that come from different sources, it has to be coming in the same format. That a data warehouse should bring together your data and make it available basically later on to do some queries at large scale, data processing, and hopefully across the organization, you know, assuming that people should be accessing the data, will be able to do some kind of BI at the end of that analysis. Another reason is quality, consistency, and accuracy. So, so for data warehouse, again, to consolidate data, besides just standardizing the format and having a uniform format, making it available for querying. And for that, the data has to be accurate, it has to be consistent, high quality. So the table should all contain data that reflects the business at the same point in time. And of course, the main purpose of data warehouse isn't just simply store the data, but to make that data readily available for analysis. That's the main purpose. And we don't want to just say, okay, we can analyze it, but it will take a day to run this query. We want to have this high speed query performance as well. So it doesn't make sense to have results of BI or to make those business decisions 24 hours later than what is needed. So we need to look out for high performance and speed with the accuracy that we talked about in the previous slide. So what does kind of a data warehouse modern? So we're looking at scale here. So instead of gigabytes, we're talking about terabytes, petabytes scale. That's going to be available for us to do that at scale. And ideally, we're going to use the word serverless and no ops. And here we don't want to have to worry about the overhead. We don't have to worry about managing the infrastructure. We only want to store data and run the analysis and run our ad hoc queries, whatever the case might be. And pretty much anything else that from maintenance perspective, we want that some kind of a managed service that do that for us. So we'll focus our energy all in basically getting insights from our data. And we want kind of a nice ecosystem of visualization and reporting tool that work together with our data warehouse, because usually this is like a human nature. You know, people like to see dashboards rather than see tables and rows of columns to figure out where is kind of the insights to get and the spots from data that we want to get. But visualization makes a lot of sense, makes kind of very easy, very fast decisions based on graphs and things like that. So we'll be able to incorporate that with our data warehouse, and an ecosystem of ETL, so extract, transform, and load data processing tools, where we can use our data warehouse both as an input, as a source of data, and as an output, as a sink where we store our data outside at the end of the processing. And obviously up to the minute data. So the pipelines that we are building using data warehouse should be capable of constantly refreshing the data and keeping it up to date. So we want to be able to access up to the minute data, and this goes back to especially reporting tools, dashboards that refresh when the data is changing, and so on and so forth. And machine learning. So it would be nice if we want to be able to use our data warehouse as a staging ground for machine learning. But not only that, ideally, we would like to be able to do machine learning within the data warehouse if possible, if that's capability. That makes life a lot easier for data scientists, for machine learning engineers alike, to work with data engineers to prepare that data for them, so they all having access to the same repo. and basically having capabilities to run their machine learning algorithms within the data warehouse. And then finally, if we're talking about moving data around, we want to think about security, super important as well. So we want to be able to impose enterprise-grade security, like, for example, data exfiltration constraints at the same time, but we'll be able to share data and queries with collaborators, having the ability to have granular access to different things, not just data sets, maybe tables, maybe rows, maybe columns, to different teams, depending on the requirement that we have. So if we compare data lakes versus data warehouses, so when you are migrating your data to the cloud, you are maybe having maybe two major choices to try to do. You have data lake where you just store all your data, raw data in one place, or a data warehouse, and it's important to understand the difference. So a data lake is a place where you can you can capture every aspect of your business operations, different formats, and we keep actually the data in its natural form, maybe the raw format of that, whatever the format might be, and we want to be able to support all data types: structured data, unstructured data, whatever, semi-structured data, objects, and also adapt to changes easily. So the data is in the data lake will often be stored as blob or files, binaries, and on the other hand, a data warehouse is set up with analytics in mind. So data is often loaded when its use cases is more defined, and in that case, we'll be looking at structured data when we're talking about data warehouses instead of just objects and binaries in them. So the goal of a data warehouse is to provide faster insights than the data lake or some other non-consolidated data source can offer. So we'll be able to work with current and historical data for reporting, and it tends to have consistent schema shared across all the applications. So this unified format that we need on the data warehouse, and like what we have on data lake, what we have any format in there pretty much. So very often we want to have the schema to be consistent for the sake of being able to do analysis across a unified kind of data format pretty much. On the other hand, the data warehouses is much more kind of thoughtful process to design it. You might load the data into data warehouse only after you have a schema defined and the use case identified. So you might take the raw data that exists in a data lake, do some kind of transformation, organize it, clean it up, remove duplicates, remove null values, this kind of stuff. So put it in the right format that the data warehouse will kind of be able to do analysis on it. And while we're getting the data into warehouse, maybe because the data is in the data warehouse is used to generate these dashboards and these charts and these reports, etc. And the idea is that because the schema is consistent and is shared across all of the application, someone can go ahead and do the analysis of the data, derive insights from it, and get this kind of business intelligence out of it so much faster. So data warehouse tends to be, like I said, structured and semi-structured data that is organized and placed in a format that makes it conductive for querying and doing analysis and creating dashboards and reports from it. And the complete picture here, this is what we want to get at the end. So we want to have, for when we talk about data lake, sorry. So if I bring my laser pointer here, we want to bring data from any type of backend database, different sources, different locations, and we store it as in the raw format in the data lake. And here in between, we should have some kind of a data transformation process where we're going to unify kind of all these data sources into one schema that the data warehouse will load. And from there, we can use this data warehouse for different purposes. We can do reporting and dashboarding, so BI pipeline in here. We might load this data to another data warehouse for other purposes, and basically preparing it for our data engineers, data scientists, doing some feature engineering pipelines and getting it ready as an input for machine learning models as well. So what is the data lake in GCP? This is what we're going to be looking at cloud storage. So cloud storage is our kind of go-to product when it comes to talking about data lakes, because we can put anything in there, any type of data, we can load it in there. And it's persistent, it's got durability in there, strong consistency, availability, high throughput. So all those kind of data lake properties that we want, that we spoke about in a couple of slides ago, cloud storage will satisfy those. Cloud storage got all these capabilities in them. It is elastic and it's scalable across multiple regions across the globe, sitting above a very powerful infrastructure, super fast network as well that Google has is owning. So how does it work? So cloud storage, basically, if you had the term buckets. So a bucket is a container that you would create in Google Cloud. And in there, you will have these buckets that are physically located in different regions, or you might have like one region. The region is basically a geographical location where Google will have data centers. So each region will have 3 data centers. So if you have like a regional bucket, which it means that you will create in a bucket that is data that is replicated in 3 data centers. You might have like dual regional buckets, and they will be replicated across 3 data centers in 2 regions, and you have multi-regional ones as well. And Google guarantees won't let you read these 9s here, the 11 9s in here. So highly durable there. So Google will take care of that they're not losing your data. There is a super powerful storage system with all the replications and the backups and things like that. That Google will guarantee that you will not lose your data in there. And also in there you will have objects in here, and objects basically they have metadata with them, and you can store any type of data in these buckets as well. And you can think of cloud storage as a Google Drive, for example, with a lot of sophistication on top of that in order to give you this enterprise solution for data lake. And it comes with different storage classes, and they serve different purposes in there. So you have standard, nearline, cold line, and archive, depending on what kind of frequency I'm accessing this data. So hot data that is accessed so frequently, minimum storage duration is none. So this is the most expensive one. Nearline for backups, data that is accessed less than once a month, and it's you've got some retrieval costs with it. The more you go to this cheaper storage classes, you get a more retrieval cost with that. And with the cloud storage, you can simulate, or you can emulate a file system hierarchy, but it's not a file system as such, because the objects inside cloud storage, they are immutable. So for example, if you change or edit a file, it will be creating a new version of it. So in that case, if you want to go back to the changes you done previous to that, you will have to enable what we call versioning in the cloud storage bucket. And in here, when we say the naming, the long object name here, simulate a file structure. So there is no folders in Google Cloud Storage buckets. So here you have probably this is your storage bucket name here, DE class, and this folder structure is part of the name of the file. So whatever comes after the DE module 02 script, this is a naming of the file, just to give it a kind of a simulation of a folder structure in there. So just to be mindful of that as well. So it's not a file system as such. And it comes with many capabilities where you want to manage those objects. So you've got a retention policy, versioning that I spoke about, so you can enable versioning, so you can go to previous versions on there. And the storage classes that we talked about, we can change these storage classes if you want to minimize costs as well. And to control access, you've got 2 levels of controlling access. You can give access to what we call, we use IAM policies or IAM rules at the bucket level. But you also, like we said, we remember the question we caused about data lake, can you give granular access to objects? And here in cloud storage, you give what we call use access control list in order to give access to the object inside the bucket. And when it comes to encryption, you've got different types of encryption there that is enabled for you by default. You've got these Google managed encryption keys. You have customer managed encryption keys, or third type, you got customer supplied encryption keys. So you can manage the encryption yourself, or bring your encryption keys, or let Google manage the for you. Or you can do the full process, store encryption keys outside of Google, and manage that as well. But the risk with that is if you lose the encryption keys for the storage bucket, Google won't be able to help you to decrypt your data. So let me just bring in my console in here and just do you a quick demo about the cloud storage. So here, if I go to cloud storage here, so what you will see is this one here. So what I can do is call it GDG MENA demo. So you give it a name. The name has to be unique because with cloud storage, you can actually share data publicly. So, and what is that will be part of the URL, and the URL is part of the URI for Google storage, Google Cloud storage, and the what dictates the use of that URL is basically this unique name that I'm going to be using globally. So if I do demo, for example, I don't have a demo cloud storage bucket in my project, but somebody else using cloud storage somewhere in the world, they already use this bucket name. So I'll go with something that is unique. And then I can decide about high availability of my data. So I can say regional, like we talked about, dual regional, multi-regional. So these are all possibilities in here. And you can see the retrieval cost when you talk about classes a little bit later. So multi-regional, like I said, in multi-regions in EU or US and Asia, the highest availability. So your data will be replicated in multiple geographical locations. Dual regional, 2 regions in America or Europe or Asia, and you specify what the regions are. And we say region is 3 data centers replicated, so it will be 6 data centers where the data is replicated. Or you can go for only regional in there, so I can go with that as well. So, and then the classes that we talked about. So if I just maybe go back here, the standard and the nearline and the cold line and the archive that we spoke about, and watch out for the pricing here. So nearline is half the price, cold line is the cheapest, archive is the cheapest of all. But you know, in terms of performance and access and the API and things, they are all the same. Retrieval speed is the same across all the classes, so it's milliseconds to the first byte. But like I said, the other ones, they incur retrieval costs. So the standard, you've got no retrieval cost whatsoever. It's free. But when you go to nearline, you start getting charged for retrieval for the other ones. So just be mindful of don't put frequently accessed data into storage class that is kind of expensive. So it can cost you a lot of money. Where if you're thinking that you're saving money, but in fact the retrieval cost will take your price higher. And then for access control, like I said, you will have uniform, which means using at the bucket level, and this will give you all the objects inside the bucket will inherit the permissions that I use with Cloud IAM permissions in here. And I've got fine-grained the ACLs if I want to be more granular inside the objects in there. And then I can specify object versioning that we talked about, retention policy, data encryption that we spoke about, Google managed or customer managed CMEK in here. And then I want to create this bucket, and it's pretty much elastic. So I haven't to completely serverless. So I didn't have to specify the size of the bucket or any compute or anything like that. So in here, I can put, if I put 1 terabyte of data today, tomorrow I want to put 1 petabyte, I can still do that because it's just going to consume storage from that, and I'm just going to pay for the storage that I want. So things like you're going to have, if you enable versioning, lifecycle management rules. So you can, if you enable versioning, you'll have many, many versions on your files. You can delete those. You can even change those storage classes. So let's say you started with standard and you realize that some files in your bucket haven't been accessed for a while, and you want to change to a cheaper storage class because you know that this is not going to be accessed for a while. So you can put it to nearline, cold line, or archive. And for the versions, you can delete version based on some particular rules. I can say based on age, number of newer versions created before a specific date, and things like that. So you can this is also possible. So you can all do this kind of stuff in with the lifecycle management rules in there. So that's a brief kind of description or kind of defining what is cloud storage and why do you use it as a data lake and how does it work and things like that. For the data warehouses, next, we'll be looking at a product in GCP BigQuery. So BigQuery is a fully managed data warehouse that is fully managed by Google for us that satisfies all the requirements for a modern data warehouse. So you can do SQL queries for large data sets, petabytes in seconds, serverless no ops. Again, you don't have to provision the cluster underneath. You don't have to worry about auto scaling. You don't have to worry about any of those patching and maintenance jobs that you would usually do on premise. You can do visualization and reporting with a couple of tools that are available on GCP. You've got Data Studio linked with integrated natively with BigQuery, so you can do visualization for your dashboards with the data when you finish that, when you finish the analytics or the queries to get the results. And you can do a lot of ETL for data processing with the SQL that is available, and you can link it to other tools as well in GCP to help you pretty much do data transformations, up to the minute data, so you always do your data up to date. You've got also capabilities of machine learning with that, so we call it BigQuery ML. So BigQuery ML, you get pretty much being able to do machine learning algorithms on structured data with SQL statement. So just a SQL statement create model, evaluate model, predict. So you don't have to write a single line of code in TensorFlow or anything like that. So we've got a super powerful capabilities with machine learning and taking advantage of the compute that is available for the query engine to do machine learning at scale as well. And security collaboration, you can share data sets, tables, and you can give access to granular access to data sets, to tables, to columns, to rows and things like that. So pretty much this is I already talked about that. Interactive SQL queries, the standard SQL really. Serverless no ops, there's nothing to manage in there. Visualization tool, you can integrate things like Data Studio, Tableau, Looker, things like that. And there is a vast ecosystem as well for ETL and data processing tools for GCP. So we can leverage those and basically do our transformation and then load our data to in a unified schema into BigQuery. Up to min data, okay, so it can work with streaming data into BigQuery. That's also capabilities of with 1 digit second latency. Machine learning, so a lot of capabilities of machine learning as well, and finally have full control who have access on our data in BigQuery. So serverless, so like I said, you don't have to do anything of those things that you usually do on-prem, backups, storage management, fault recovery, issues with the hardware, optimization of the query engine, updates, patching, all those kinds of stuff. That's all done for you by the service as a serverless managed system. And it's super fast. So let me just do a quick demo in here and come back and explain why is it fast and what is it doing under the hood in order to give us that capability of being able to do queries at a larger scale in seconds rather than minutes, hours, or even in some instances days. So if I go back to my BigQuery here. And what I'm going to do, I'm going to just run a couple of queries here. Let me bring them from my history here. So if I bring, okay, probably not this one. I'm just going to go. Okay, so I've got a public data set I'm going to run some queries on. So I'm just going to go for, I've got this table, 100 million records. I just want to do a select language title, aggregation of views, and just do a filtering around the word Google from this table in that data set. So if I look at this data set here, it's not massive. So we're looking at, look at the details here, 8.4 gigabytes of table size and 125 millions or thereabouts number of rows. So if I run this query, and if I have a look at the results here, execution details, and that's because I did run it earlier. So it works from cache. This is one of the capabilities here. It uses a cache, so I can minimize, I can disable that. So to see how long really it takes. I don't want to run from cache. So if I run this again, so you see here, no cache results. If I look at execution, just bring that down. So 2 seconds. Notice here I've got elapsed time and I've got slot time consumed. So what I'm gonna do, I'm gonna scale it a little bit here to 1 billion records. So if you look at this data set here, details, the table size now is 84, 10 times the size, and we're looking at 1.25 billion records in that table. I'm gonna run the same query. And notice here, I've just got this window in here, it's completely serverless. I'm not having to provision any compute to run this query at all. So, and it came back in 12 seconds. Oh, it hasn't finished yet, sorry. So, yeah, 13 seconds this time, and 18 minutes slot time. So what does it mean, a slot? A slot is a compute unit that is part of the query engine. So the idea of Bigquery is like two services. It's got like a storage service where the data is, and you have the compute power, the query engine, which is a cluster of compute units we call slots. So here, if you want to know a number of slots that runs this query, basically I would divide roughly 18 minutes 51 seconds by 13 seconds. I would know how much Bigquery is giving me, how many slots it gives me to run this query. So the underlying infrastructure is completely serverless, and the reason that each time I'm getting different number of slots, because Bigquery will analyze the complexity of my query. It will analyze the size of the table that I'm going to be running, and it will give me the number of slots I'm going to need to do here. And the reason it can do it kind of elastically and dynamically like this, because storage and compute are completely separate, so decoupled and connected through a very super powerful network in between. So super fast network, which allows this kind of auto scaling to happen super efficiently. So if you need more slots, more compute, you're just gonna give it more compute. The data is not coupled with the compute at all. So I'll be able to do scaling super fast in here. So if I want to scale this to, let's say, 10 billion, so I will get a different configuration with a different number of slots. So this one here, if I look at this one, what you will get is the table size is over 0.5 terabyte, and we're talking about nearly 11 billion records in here. So if I run this query, what you will get execution details, 9 seconds. So and if I was to run it on one slot of the, it will have taken 1 hour 9 minutes. Now Google are giving me a number of slots in order to get it back in 9 seconds. And I can use cache, for example. So if I want to use cache for here, if I want to run this query again, because I do get charged for this amount of storage when this query is run, so I can enable the caching. And when I enable caching, if I run this query again, it's going to come back in 0 seconds. It's going to read that data from the, but it looks like it hasn't enabled the caching yet. So let me just go back here. Has it done it? No, sorry, didn't do that. So query setting again. Yeah, still enabled, so I didn't save that. Run that again. And my mouse is playing up, so it's not. Go back to query setting. Save this. Give it a couple of seconds to enable the cache, and I'm going to run it again in a second, because here is, let me just take that out. Run again. There you go. Yes, so it didn't pick up on, so now elapsed time is nothing. So if I run it again, it's going to come back. So I'm not going to charge for anything in that case. So it's picking up the data or the results from the cache. So the cache get invalidated after 24 hours, or if the backend data will basically change any data, the table data changes, it will invalidate the cache. It will run the query, so it gives you fresh results in there. And I can visualize that with Data Studio. So just with a click of the button, it will take me to Data Studio, and I can do any type of dashboarding in here. So I can do, let's see, I can take it and do a pie chart here, and there you go. So do the breakdown of that query with the functioning on different languages, grouped by different languages for the word Google. So you can see the breakdown with the actually like this, or I can do this one, or yeah, whichever. So super powerful. And on top of that, like I said, you can do you can run machine learning just with a SQL statement in here, but we're probably going to do that in another session in there. Again, why is it super fast? Because a couple of things here: decoupling of storage and compute. And the storage itself, the columns are stored in files, in the columns in the storage itself. So it's a column based storage that Bigquery uses, and in that case it will be super fast. So if you have like a normal database, when you do querying and you do select column from that, it will bring basically the rows as files, and then it will select the items, the columns that you selected from them. Whereas in Bigquery, it will bring out, if you select column 1, column 2, is not going to bring all the row. It's just going to specifically bring that row from the storage. So it will be super fast, and it will take less time, and it's going to cost you less because you're dealing with less storage in there. So that's the idea behind how is it too fast. First of all, decoupling of storage and compute, and the storage is stored in columns. So each column is stored in separate file, and then in the backend storage, which is, we call it Colossus. And again, you can see here, this is, you got the compute and you got the storage completely separate through this petabit network. So if I need to scale, I can put more compute and I will read the data from the storage. So there is no data stored with the nodes or the compute units. So if I downscale, I'm not losing any data. If I want to add more compute, I can just throw more compute in here and get the data to be able to run those complex queries. So it can deal with streaming and batch as well. And you can do queries from the web UI, from the CLI, and it's the standard SQL that you have in there as well. So Colossus is the name for the backend storage. The Jupyter is the network, the internal network of Google. That's 1 petabit per second network that linking the storage and compute. And these capabilities of having to do auto scaling with kind of depending on the capabilities of the complexity of the query and number of storage, basically you will be able to consume resources as and when you need them for the right demand. So you will never be over provisioning or under provisioning. So you get allocation and the consumption the same. So if you need 4 nodes or 4 worker nodes with for the particular query, it gives you exactly the CPU memory that you need for that. So you will never be in having some, not like on-prem. On-prem, you have a cluster of resources that you already have a massive, probably upfront investment for that. And sometimes you run analytics on it. Sometimes the jobs are big, so you probably struggle for resources, and in that case, you will be under provisioning. And sometimes they would be sitting there doing nothing because you are running like small jobs and things, so you're not taking advantage, leveraging the full capability of that. Whereas in the cloud, it's always kind of the consumption and allocation, the on-demand storage and compute with the allocation that is required, always the same. So I'm not over provisioning and I'm not under provisioning. And like I said, these slots is basically some CPU, some RAM, and some network that you basically get given when you create those queries. So it will be different. So BigQuery gives you a number of slots in order to run the query, depending on how the amount of data that is in there and the complexity of the queries that you have. So under the hoods, how does it work logically? How is the data stored? So you'll have in GCP, you have projects. So any resource you want to create in GCP, you would need to have a project, because the project, this is where you get billed for resources. So BigQuery is no different. You have projects. In the project, you have data sets. Like here, when you saw me do that, so you got here data sets in here, and these are my data sets. And in the data sets, you have tables, different tables in here. So this is the structure that we're looking at here, and you can have different projects with different data sets and different tables underneath them. Again, project data sets, tables, and physically you'll have storage and compute separate. And yeah, so data set belongs to a project, and then you have access control as well. So you can give access similar to cloud storage buckets with what we call cloud IAM roles with permissions either at the dataset level or the table level, and you can do it at the column and the row level as well. And similar to what you have in cloud storage, here you have also datasets that are regional, multi-regional. So if I create a dataset under my project, for example, and here I can just give it a name. I might call it GCP MENA. Yeah, and for the location, I can specify multi-regional or regional, so I can specify those if I want to, and create data set. So basically, data will be replicated across multiple regions. So here we can you can also get data from not just within the storage of BigQuery. You can actually get data from cloud storage as well, or from Google Sheets, for example, or things like that. So that's all possible. So where does BigLake comes into the picture? So what is BigLake to start with, and why do we use it? So BigLake is a name given by Google to an underlying access engine used to provide access to data stored in either BigQuery or in structured format stored in Google Storage buckets. So the concept is that data owners, usually what you have data that is stored in data lake, and then you replicate that, you basically do transformation to it and move it to BigQuery. But sometimes you can store structured data in Google Cloud Storage, but the access mechanism is not the same. So you will have your different access rights with different kind of IAM rules for BigQuery, IAM rules for GCS. They are separate. So with the data stored in distinct places, the access patterns, the properties, they differ. For example, there are things one can do with data stored in data warehouse that someone else can't do with data stored in data lake. So there is kind of limitation of what you can do with structured data on on Google Cloud Storage buckets. So BigLake gives you that mechanism in order to access that data and have the capabilities of BigQuery to, as if they are the tables, they are the same as you have control over them, as if they are natively native tables within BigQuery. And so it does provide you that platform in which kind of unification of common access that can be achieved by providing a single interface and to access the data irrespective where it is physically resides, whether it's in BigQuery or cloud storage. So the thing that we've seen with BigQuery native tables, imagine that you have tables that are owned by BigQuery, and in this case, there is nothing further to do, as you already immediately access the data in the table, so there's no issues in them. When it comes to data that is stored in cloud storage bucket, now imagine the alternative case where you have the data stored as object in GCS. What we now do is create what appears to be a BigQuery table, but kind of the source of the data for that table at the underlying cloud storage bucket. And once you do that, we have this ability to query or retrieve data from this BigQuery table, and BigLake take care of the retrieving and serving that data for you. So we now see that we can access the data using BigQuery interface and no longer have to immediate knowledge basically where physically the data is. So for us, it's just like BigQuery can access it through this layer that BigLake will offer to us to give you kind of uniformity of access of data as if it's in BigQuery. Whether data is a native BigQuery table or stored as object in cloud storage is hidden from us as consumers to consume that data that is there. But we know that in Google Cloud Storage data, we can use external tables as well. So what is the big deal when we bring kind of BigLake in the picture? So if you are familiar with BigQuery already, you might be scratching your head at the moment. So you may be saying that doesn't BigQuery already have these concepts of external tables? And it does, actually. You are absolutely right. But the idea of external tables has been in BigQuery for quite some time. Just like BigTable or BigLake, sorry, BigLake external tables provide you with a BigQuery interface onto the underlying data that is stored outside BigQuery, including cloud storage buckets, Google Sheets, Google Drive, all those kinds of stuff. You can have that interface from BigQuery into that. And again, what BigLake currently provide is this alternative interface that is designed to provide you with this unified data warehouse, data lake / data lake interface. So in the initial set of BigLake functions, so you're given an immediate kind of advantage with BigQuery external tables. So you're given an opportunity to perform again finer grained security at the row and column level, whereas with the native external tables on cloud storage, you won't be able to do that. So just to make that crystal clear here, we can now have a structured data stored in GCS, and the access, you can do it at the row level, at the column level, as if the tables are natively BigQuery tables. So this is kind of the advantage in here. Another distinction from external tables is that to query a BigQuery table mapped to an external source, then the identity submitting the query would normally to have read permissions on the underlying data source. For example, if you have like external tables mapped to Google Cloud Storage bucket, you would require that the identity executing the query would need table permissions and also permissions on the object on the Cloud Storage bucket. But with BigLake, basically BigLake get authorized to have the GCS object permissions, and then the identity running the query is exclusively allowed or denied based on the BigQuery permissions. It has nothing to do with the permissions that are on the cloud storage bucket. So kind of really useful in here to get this uniformity. And for us users, we consume the data. We don't care where the data is. Is it sitting on BigQuery or cloud storage? It doesn't make a difference for us. We just want to get insights from that, run our queries, and be able to get those results. Do visualization if you want afterwards. So let me just go and probably do in the next few minutes just do a demo for this. Let me just bring in the console again, and what we can do, we can have a look at an example of how do we bring in a data from cloud storage into using BigLake into BigQuery. So let me just go to the cloud storage buckets here. So if we go back to my cloud storage here. Okay, all right, let me just open the console with cloud storage here on another tab because I need BigQuery in a second here. Let me close that. And I'm just open this in a new tab. I've got GCP MENA demo here, so I already created that bucket. Let me see if it's a multi-regional because I need to have a. Let me delete that. I need to make a multi-regional similar to the what we're going to do a data set that is multi-regional, so I have them both the same. Otherwise, I won't be able to read data in BigQuery from a multi-regional bucket into from a multi-regional data set into bringing it to a regional bucket in here. So delete that. I'm gonna. Oh, I've got this demo BigLake. Okay, let me just have created a couple of minutes ago. So let me delete those. Objects. Okay, I've got some data in here. Let me just bring in this data. So I've got a CSV file here. If I can show that. It's not coming up. Let me just upload it here and then we'll have a look at it. So I've got okay, we've got this demo file here. It's got CSV file, country, product, price. It's a simple file here, CSV file. And I'm going to bring the second one. It doesn't look like this is this CSV. Yeah, I'll work with the second one, the BigLake CSV. Delete this one. Okay. So now what I want to do, I want to use BigLake to bring in this table into BigQuery. So if I go back to BigQuery here, I'm going to go BigQuery, and I've got a data set already in here. So what I can do, I can create a table from cloud storage buckets. It's a CSV. I'm going to give it a name, BigLake. Table is external, and I'm going to bring it from a BigLake connection, source connection. So I think it's this one, or I can create a new one actually. Just to let's call it GTG MENA in here. Data location, US multi-region. So because it got multi-regional data set in there, friendly name again, GCP MENA. Create this connection. There you go. And I'm going to create my table. Okay, I didn't specify the file here. What is the it's demo demo BigLake? There you go. this one. Click CSV, select that, create table. And if you look at my connections in here, and I look at this GDG MENA in here, so what I can do here, this service account now, if I want to run queries from that table, I need to give it access to cloud storage bucket. So I can go to Cloud IAM, and I'm going to give it read access to the object that is I'm bringing in with data lake. And then I can do whatever I want to on with the permissions with BigQuery. So I can bring that service account, give it storage viewer, read only to just run queries on it. So storage object viewer, save. Okay. So now if I want to, where is my table that I've brought in? So you can see here, this is the table that I brought in here, BigLake. Okay, I can run query in a new tab. Is that the one that we brought in? I think it was. So if I do edit schema, let me delete it. Got it and brought the schema with it. So tick box probably that I missed. I do that again. Create table quickly. Google Cloud Storage. Demo BigLake. BigLake CSV. Select external. Auto detect schema. I think this one that I missed there. And used to use a connection. GDG MENA. That's got all the permissions. Create. That's better. Details. If I do run my query now, there you go. So this is my data that came in through that. So I can now give permissions to that using native BigQuery permissions. I can give row level permissions. I can give column level permissions, so I can actually apply directly those policies. So I can do something like, let me see here, if I bring the query to apply the policy. So what I can do is my console here on another query and another query here. Second, and DE 191012. Just gonna type this query here and I brought it to 191020. Dot. Okay. just to apply a policy. If that works for us, that would be great. Okay. So policy looks something like that. So if I open query here to give row level access only to that, so it will look something like here, create row access policy. And let me just that works. Yeah, 1 second. So I think this dash is here. That's the issue. Okay, there you go. So I'm creating here a policy to give my account just row access to from this data, just for the US country US. So if I apply this policy here, now on that table that is sitting in cloud storage bucket, even this external table, but I'm getting kind of capabilities of running policies as if it's a native table in Bigquery. So if I run this query again now, let's see if that works. Yes. So it doesn't give me access to other rows, just the row what the US is. So you can see here what kind of BigLake is giving me to be able to apply policies in tables that are sitting in cloud storage as if they are native tables sitting in Bigquery storage here. All right, that's all I've got for you in this session. Thank you very much for being with us. And if there is any questions, happy to take them now. Otherwise, you can reach out to me. I think my Twitter, my LinkedIn is going to be shared. If you have any questions about this session or any of GCP topics, happy to answer those questions. And thank you again. Check the chat if there is anything. Otherwise, have let me give it a minute or so people they not say that I'm running away. Let's see if there's anything in the. Even the question is in Arabic. I will take that. I will entertain questions in Arabic as well if there is anything. All right. I haven't seen anything coming up, so thank you very much. See you on future set. There is a question. Okay. Let's see. Not too fast. I can't see the question. You can put it on the chat for me. اوكي، كيف يمكن المضيف قدما في دمج بيج ليك في مشروع تكنولوجيا المعلومات؟ كيف يتم تنفيذ قائمة سلاسل تعليمات جوجل الأعوام من خلال وحدة تحكم افتراضية المنصة؟ شكرا. اوكي، بيج ليك مثل ما قلت هو يدمج يعني تكنولوجيتين في الجوجل كلاود اللي هي كلاود ستورج والبيج كويري. اعتقد انه اول شيء يعني تكون عندك عليه معلومات وتتعلم عليه هو البيج كويري والكلاود ستورج. اول شيء اول كانت تكنولوجيات اللي بيج ليك يساعدنا هو لما يكون عندنا معلومات او داتا في الكلاود ستورج ونريد انه نقرا هذه الداتا ونتحكم فيها والتحكم في السكيورتي على انها بيكويري داتا. فاول شيء هو البيكويري والكلاود ستورج، وبعدين البيج ليك يكون المستوى الثاني اللي يكون فوق هذا هذه التكنولوجيتين اللي في الكلاود ستورج. كيف تأكيد النشر الصحيح؟ كيف يمكن تأكيد النشر الصحيح بيجليك؟ والله ممكن توضح السؤال أكثر؟ كيف يمكن تأكيد النشر الصحيح بيجليك؟ Okay, how to assert the correct deployment of BigLake. Okay, so النشر الصحيح the correct deployment يعني لما كنت انا على المنصه على بتاع جوجل كلاود، ما عنديش ستورج فور بيج ليك. ما هو ستورج اللي يعني اريد اني اتحكم فيه، لكن هو اللاير، يعني هو كونكتيفيتي اللي تساعدني اني الكونكت اتواصل من البيكويري لكلاود ستورج. فاتاكد من السكيورتي اولا، من السكيورتي تاع الكلاود ستورج، من اللي عنده التحكم في الباكيت، الفايلز اللي في الباكيت اولا، من هم التيمز اللي معايا ولا الاشخاص اللي عندهم اكسس ايذر ريد رايت اور وات ايفر. لكن من بيكويري تحتاج فقط الريد اونلي، لانك راح تراني راح تقرا المعلومه فقط، ما راح تكتب عليها ولا تضيف عليها اي شيء. فالبيكويري will ساعد to run the queries، يعني حتى تحصل الانفورميشن اللي في الفايل. وبعدين لما تكون عندك you set the connection مثل ما واوضحت في الديمو، تعمل كونكشن. لو ارجع هنا لو ارجع للبيكويري هنا، انا سويت كونكشن هير، اكسترنال كونكشن تو بيج ليك اللي سميتها جي دي جي مينا. وهذه تستعمل السيرفيس اكونت. السيرفيس اكونت هو مثل ان ايدنتيتي اللي عندها اكسس تو كلاود ستورج. سو هذا الاكونت اللي يعني استعملته حتى احدثت هذا التواصل بين البيكويري وكلاود ستورج. اعطيت له اكسس للكلاود ستورج. لو لاحظت رحت للكلاود اي ام واضفت لهذا الاكونت، اعطيت له ستورج ريد اونلي. واضح؟ سو ستورج ريد تو اوبجكت، حتى يتمكن هذا الكونكشن، حتى تتمكن ان تقرا المعلومه فقط، ما تضيف عليها ستورج فيور، اوبجكت فيور. الفايل هذاك اللي كان في الكلاود ستورج باكيت اللي كنت انا اريد اتحصل على المعلومات منه، اعمل عليه كويريز، اعطيت له فقط اوبجكت فيور. فالان هذا الكونكشن اللي عندي هنا، اللي عندها البيج ليك، راح تتحصل على المعلومه من كلاود ستورج باكيت، وتقدر تعمل عليها كويريز ونعمل عليها اشياء اكثر من النورمال اكسترنال تيبلز. يعني لاحظت هنا، عملت هنا البوليسي مثلا اللي تعطيني اكسس فقط للكونتري يو اس. سو من قبل كان عندي اكسس لكل الروز هنا، اليو اس، جابان اعتقد، و other things. الان ممكن ان الفايل تبعي عندي users in different regions. فهذا الفايل اللي حطيته هنا we talking about big data، احنا نتكلم على معلومات at scale. يعني الفايل يكون عنده ملايين تاع المعلومات في بلدان مختلفه، اليو اس، ممكن الجزائر، ممكن الامارات، ممكن. فكل فريق اللي في موجود ريجن راح اعطي له البوليسي من الفايل اللي راه في كلاود ستورج باكيت، ونقول اوكي جيف اكسس بوليسي فقط لهذا الروز اللي في اليو اس ولا في الامارات ولا في الجزائر. فهذا يعني الادفانتجز، يعني البيج ليك اللي gives you. otherwise لو ما عندك البيج ليك راح ما تقدر تستطيع تعمل اشياء مثل هذه، انك تعطي الاكسس فقط في مناطق معينه لاشخاص معينين في بلد معين. ان شاء الله الجواب واضح ان شاء الله. اسئله اخرى؟ لو في اسئله اخرى اخذها، او اوكي، ما فيش أسئلة. again شكرا لكم في بقائكم معنا في حصة من حصص الجي مينا. Thank you so much for being with us this evening. إن شاء الله راح نشوفكم في حصص قادمة في مواضيع أخرى إن شاء الله في الجوجل كلاود. Thank you so much. Have a good evening. السلام عليكم.